you have your nice software, now you need to get some unknowns, do some science on the data produced by this software. You give the test to your data science, saying like, guys, I want to figure out what's happening in this business process, and they say, well, there's no data, and the data is not clean, or there's a lot of disconnections between different business processes, so they just can't figure it out, and they just run around the office asking software engineers to put some logging or whatever it is to get more cleaner data. And yeah, so actually data in business applications, I'm talking about business applications here mostly because my background is mostly retail and logistics and transport, some bank solutions. And in business applications, what we have? We have transactions. And transaction is something atomic, right? It just happened and you've written it into your database, and you only actually create transactions, right? But what we also have in business applications is objects, right? By objects I mean some entities like user profiles, or maybe some profiles of drivers, profiles of your employees, profiles of assets like vehicles, for example, or facilities, whatever it might be. And the way we create software, the way we actually, yeah, that's the problem with this technology. So the way we usually the way we frame our requirements for software engineers to create systems is actually the way which prevents them for creating software which preserves data. Because you say, I want this feature which allows me to update the profile of a user or allows a user to update some profile. And yeah, databases, pretty much all databases have this feature to update stuff. But yeah, that's actually what happens. And then there are obviously two problems. First of all, there are also user stories which say that, well, I need to be able to delete some data. I need to be able to delete some business process which didn't happen or mistakenly entered to the system. So please give me some delete buttons, right? And we see this in pretty much all applications that we use, and all tutorials for most of the new technologies that you can find on the web. They are all about CRUD systems, create, update, delete systems. So they teach software engineers how to delete and update data, right? So this is kind of obvious thing, never delete the data if you want data scientists to figure out something on top of it. But then also an obvious backups and backup solutions should be there. But the second big problem is that we actually update data and we lose it. So I would like to argue that update is a delete. It's a delete of previous value. And for product managers, for data scientists, there's no way they can get this data back. There might be a funny example here. Like, for example, we have a customer and they have a field birthday, and this is e-commerce store, and we want to send some discount for his birthday. And if we don't have any, if we're a startup, and I'm not saying that it happened in Redmart, but you can imagine the situation then when you actually send this notification to the customer that here's your 20% discount, and they really like it, and then they change their birthday for tomorrow, and they have their discount again, and then again and again, and marketing department just doesn't understand what happens, and your engineers too, because they don't actually have logs, right? So you can't even measure the impact. Okay. Now, if there are some engineers here, they might say, no, actually we have application log, and we can just grab some logs there, from there, and tell you, build whatever reports you want. All this Elasticsearch, Logstash, and Kibana stacks can be helpful there, but first of all, it's not reliable. It's usually owned not by the team but by DevOps. And DevOps is this is basically a team which makes sure that the infrastructure works. And sometimes there's just not enough space on hard disk drives, and they just delete logs because they think they are not important. Then, actually, application logging depends on the engineer. You can't enforce high quality logs, so you should always review all logs written by engineers. And the biggest problem is probably unstructured format, which means that if you don't agree with your engineers, how would you like to write logs? How would you like to read logs? They won't write it in any particular format, so they will always write it in a free text, like customer profile updated, or customer profile with this ID updated. But they will probably not write a message, customer profile ID updated, and the birthday previous value was this and now it's this, right? So, for example, we'll take a cart in e-commerce grocery store. The difference of grocery store from, for example, fashion store is that the cart is actually created not in one day. It might take maybe a couple of weeks to fill the cart, right? So you see that your milk is running out, and you just add it to the cart, and the same for other products. And you keep creating your cart for maybe a couple of days or a couple of weeks, and then you finally create an order. So if you just design a cart in a way that you update it every time the item is added, so it's just an update, right? You can't infer the behavior of the customer. You can't see when he was adding, when they, customers, were adding different items. You can't build reports which show the behavior of the customers, which allows you to clusterize behaviors. Like some customers create carts in several days, and they put most of the products in the beginning of these days, and then they just wait for a couple of days to make sure that they ordered everything they wanted, and then they click order. Or maybe some customers, they just they do it uniformly throughout these days, right? Maybe some customers delete products from the cart for some reason, and you want to make sure that they, at least you want to understand what happens. Now another example is driver profile. So driver profile is just a very simple thing. You want to know which employee drives which vehicle, so you create a user story for engineers saying, like, I want to have a screen which allows me to enter driver profiles with their particulars, their names, their birthdays, maybe some phone numbers, whatever it is. And then, you give this UI to managers of these drivers, and these managers, they change stuff. And sometimes you just don't know for which reason they have changed this profile. For example, they might say, I don't want to create a new driver. This driver just quit, so I will reuse this ID. So he changes the name, he changes all the details, and it's a new driver for him. It looks like a new driver, but if you go to the data warehouse, it's the same ID. So that's a big problem. Of course, there's a problem of UI. Probably we should not allow this on the first hand, but what if we try to figure out how to build software so that it never happens? Another example, it's a shipment, right? You can think about it as an international shipment, and there is a tracking process of international shipments, right? If you order something from Amazon to Singapore, DHL delivers it to you. You have a tracking number. You go to the website and you see what happens, who actually did the change, where it has happened. And where, meaning it might be a GPS location, or it might be a facility, there might be a less business process happening, meaning that customer clearance, for example, or processing, whatever it is. So you know what happens to the entity all the time, right? Now let's look at the very simple scenario. You want to, as a product manager, you want to design a RSVP for a conference. So you have basically two user stories. One is that as a conference host, I want to be able to set maximum number of participants. And then the second is, as a customer, I want to be able to reserve a spot on the conference. And probably delete myself from this participants list or change the number of people coming with me. Okay, so this is what happens. Customer comes and says, I want to make a seat reservation for 2 attendees for conference. Then we make a reservation for 2 seats. We have a database storing the conference name and then a number of bookings. This is a very simplified example, but what we store here is number of bookings. So what happens next is that there's another customer coming here, right? He issues the same request, and we just update this number. So we want to actually know what was the process of growing, how this number was growing, right? Was it uniformly throughout since our announced date, or everyone booked it the first time? From this data structure, we don't see it. Now, I just want to propose a very simple thing. It's not my invention, obviously, and this has been for a while. I mean, this architecture paradigm was there for a while, but for some reason it's not adopted yet. And I don't see many frameworks right now which really support this. I mean, in a sense, the framework which allows application developers to develop system as opposed to system engineers to develop some frameworks for them, right? Of course, system engineers can develop this from scratch, but it's better to use some frameworks. But now we can talk about it later. Now there are frameworks which allow this. That's why I'm coming here and discussing it. So event journal is an idea of not updating anything. So you just have an append-only journal. If you have well, I have next slide here. So let's say you set capacity to 100. Then you add reservation for 1. And obviously, this is an event which is triggered by a particular user at a particular moment in time using some particular user agent or whatever you want to store here. Then add another reservation, then remove reservation. So this is just a journal. And then if you want to know how many spaces left, you just run this from the beginning and you just compute 1 plus 5, 100 minus 1 minus 5 minus 2 plus 1. And you need to compute it all the time. Some frameworks allow you to store this in memory and make sure that actually access happens in the queue, so there is no concurrency, and this value is just stored in memory, not in database, and it might work really fast. The only thing that you write on disk is the event. So the main point here is log is the data. I believe that you might have data in a data warehouse, but these data should be your log. You should not have your logs separated from the data. Of course, we can talk about application logs. These logs might store some, technical details about time spent for accessing different systems and all that stuff to help software engineers to figure out what's wrong. But it should not contain any business values or any business events which will be later analyzed in data warehouses. Yeah, so this the same example for cart. You create the cart, you add the item, you set delivery time, you add another item, you change the quantity, and then you change delivery time for some reason. And now from here you can infer behavior of the customer. So to help product managers, I think it's good to have a kind of checklist for user stories, or maybe not for user stories, for releases. What things you can ask developers to build so that they actually change the architecture of the software. For example, you might want to have an audit log. Maybe later, maybe 1 year later, when your startup or your company or your business process has grown up, and now it's big, and you want to know what happens, who does what, who changes what, and why. So you need an audit process, and this process requires some UIs, obviously. So you probably need to point this to software engineers early in the beginning of the process. Now you want to have to point out that actually history of changes is something that you're looking at from the day one. And you are saying that this history of changes should be stored in the same database, and this is actually the data which is very important for business. Then you are saying that you actually care for all business entities, without any exceptions. I can tell you that driver profile might be the least important thing in the business process, but at some point in time, when you want to delegate this business process to outsource this business process externally to your partners, this matters, right? Because you want to track access, you want to track all the changes, you want to make sure that business process is followed. Then you are saying that you just want to have a simple report which says how much time was spent between different events in different entities. Like, for example, in this conference example, you want to see what's the distribution of time between different reservations. And the last one is, when you integrate two different systems, there are basically two main ways to do that. One is a scheduled approach, when you say that one system every 10 minutes pulls all the data from different systems. And then another approach is that the second system, which produces the data, actually pushes everything to all the systems, and whoever wants to read this, they read it. So if your engineers, or if you require your engineers to integrate two different systems, tell them that you don't want scheduled dependencies. You want to have event-driven dependencies, meaning that if something happens in one system, you want to have a reaction in another one instantly, not after 10 minutes. So this is just, it's not even my pet project, it's just an experiment which I ran on some business process. This is basically a graph built on top of the event log. And you see green edges are representing the business process, how it was designed. And then there are other lines, thin lines here. They show, if I didn't have the log, I would not be able to build this kind of graph. I would not be able to understand that business process is violated sometimes. And actually, of course, this edge, the width of this edge represents the number of transitions, and the color is. The color is, I guess, the color of this also represents the significance of this node. So, I wanted to show another good example. This is from a bigger system. So this is actually from healthcare in Russia. There is a network of offices where different employees can come and check for recurrent checkups, for a checkup that they should make every year. And these are different doctors and different business processes. And you see, they had a problem that the throughput was very low. So I told them, give me your event log. So it took them maybe 1 month just to grab it from different systems, which is already a problem. Now, I'm not sure that this data is clean. And you can see from this business process that it's kind of chaotic, right? It's really hard to understand what happens here. But what if this data is clean? If this data is clean, then we see that the business process is indeed chaotic, and we don't really know what happens, and there is no clear main business process except for registration process here in the beginning. So maybe the core of their throughput problem, or the throughput of their business. The throughput, I mean, how much time it takes for one guy to complete all the checks with all the doctors. Maybe this problem lies in the lack of structure here. But if you don't have a nice event log, you won't be able to build this kind of graphs. So yeah, that was my message. Basically, don't delete the data, and update is delete. And event journal is something that you need to ask your developers to build. Thank you. Yeah.
I think one of the fundamental things that prevents what you're doing from happening is the fact that developers use messaging.
Absolutely. But it's not the only problem.
But it's a big one. It's a big one. They don't even know it exists. And it solves a lot of problems for them, but they don't even know it exists.
Well, okay, I would agree with that. But from my experience, I was fortunate probably to work for companies where not only engineers, but even product managers knew what queues are. But because we get used to, so we had an excellent talk before about adopting new technologies. I mean, we touched this topic a little bit. So when you want to adopt a new technology, you go to the website of the founders of this technology, and you look for maybe a quick introduction or maybe some number of lessons. And if this is about building UIs, if this is about storage, this is pretty much all technologies that we need to learn right now because we're moving from desktop, or we moved from desktop to web and to mobile. All these technologies show you how to build CRUD applications. They show you how to create stuff, how to update stuff, and how to delete stuff. But they will never tell you that you should not use update command in the SQL or in Mongo or whatever it is. And actually, you know, there is a nice database which was there for 20 years, right, or 10 years, and they know how to build data warehouses, right? They build update for a reason. Why won't I use this? This is maybe a junior developer can tell it to you. So there should, I believe that architects, they don't always understand the importance of this stuff, and only product managers and process engineers, they really understand this. That, you know, you need to know what has happened. Process engineers need these nice features because they can see a lack of process here, and they know that they should focus probably here because there is a lot of, you know, the radius is big here, so there a lot of stuff happens here. Maybe I can start from here. And yeah, so, but architects, designers of all the systems, they don't really feel the need. So the situation is that you don't even have an opportunity to get the data, or you have this.
I want to know how you can get the data in this kind of offline scenario. Like, is there any quick fix? Say, like when you do something, then that will have a data point. You'll have to somewhere.
Okay, so the first thing is that if your system, which supports their business process, is kind of software as a service, which means that they need to log into their device or to something, the website.
Let's say a lot of things are done in
Outlook.
Yeah.
So email might be, I mean, you need to read the queue of emails of the employees, and you need to let employees know that you're actually reading their emails. So if you want to do that only with Outlook. But I can give you an interesting use case. So there is a thing called iBeacon. It's a Bluetooth low energy device, which actually you can stick it on the wall, for example, and it is used. The main use case is for malls, for shopping centers, where you can advertise different advertisements. Advertise, it's a technical term. different advertisements, promotions to customers through their phones. So you have your phone with Bluetooth switched on, you're passing by, and if the distance is small enough, you actually see some promotion. This is the main use case. But I think there is a lot of opportunities to use that in offline businesses. So if in points of contact in different offline places you put these beacons and you give your employees software installed on their mobile phone, you will actually know when they came here. But it's honestly outside the scope of this talk, because here I'm mostly talking about the fact that even if we have a perfect opportunity to store all the data, we don't do that stuff. Yeah, but we can talk more. Okay? Last question?
Besides sales, what kind of data and metrics do you guys use to determine success, short-term and long-term?
We use all the available data.
What kind of metrics though?
Huh?
What kind of metrics? Is it time spent on site? Is it number of clicks? What kind of measurements?
Well, everything you can possibly measure on the website. Of course, we use a lot of analytics software, so you can go and check. There is like a clicks, event streams. You can we use custom events on the website. We actually try to figure out the behavior of the customer. And for that, you need to know for every single moment, you need to actually know what was happening in their mind, what was the business, what was the thinking process. So yeah, it's not a joke. We try to use all the data available.